Hello students, welcome to standard 10, subject mathematics, chapter 7, coordinate geometry. This is lecture number 3. In last lecture, we have seen the distance formula and related examples. 1, 2, 3, 4, 5, 5 examples we have done. And exercise 7.1 I told you to solve. Now after exercise 7.1, which was related to distance formula, the next topic we have, the next formula we have, which is section formula. Why it is called section formula? So as we can see here, the 2 points, say A x1 y1 and B x2 y2, apart, some distance between them is there, and let the joining to both the points A and B, the line segment AB is there, and let the point P internally of this line segment here with the coordinates x and y. So we can understand by this point P, AB is divided into two parts, AB and PB. So about that it is given, let the point PXY, this PXY divides the line segment joining the points A x1 y and B x2 y2. If this P is dividing AB in some ratio, in ratio AP upon PB, the two parts by P of AP is AP and PB, and if let the AP and PB ratio is M1 upon M2, ratio of AP upon PB is M1 upon M2, that is M1 ratio M2 internally means P is inside the AB part. In next classes you will see the P may divide the AB externally also. In that case you will see that P will be outside or before A or after B. But in our course in 10th standard it is only internally dividing point is given. So always we have to take the point, dividing point inside the line segment joining the 2 points. So this way the internally what is used. So the situation is that PXY divides line segment AB joining A to B with the coordinates of A are x1, y1, B are x2, y2 and B as xy. Then the coordinates of the point PXY, which is dividing the point which is dividing the line segment joining the two given points. To find the coordinate of that, we have this formula xy equals to, we have to go this way, cross way, with the ratio and given coordinates m1 to this and m2 to this way. To remember how it will be seen, it is m1 x2, m1 when you are talking about the x coordinate of this point, so only x coordinate m1 x2 plus m2 x1 upon m1 plus m x coordinates. With the ratio of this side, we will multiply the x coordinate of that side. Ratio of that side multiplied by the coordinate of left side. So this way by cross we can remember this m1 x2 plus m2 x1 upon m1 plus m2, the sum of the ratio. Comma y coordinate is m1 y2 plus m2 y1 upon n plus n. This is known as section formula. Why this is called section formula? Because this point P has done the two section of the given line segment. Before it was only one line segment, but because of this point is this line segment is section, is partition into divided in two parts. So this point which is dividing in two parts we can get by this formula. So that's why this is called section formula. So from this section formula, the midpoint formula we will deduce. We can understand that if P point, if it is midpoint of AB, if P will be the midpoint of AB, we can understand AP equals to PB. And when you take AP upon PB, the ratio M1 upon M2, AP and PB will be equal, AP PB equal. So M1 upon M2 will become 1. 1 can be written as 1 upon 1, means the ratio will be 1:1. In case of M1, M2, it will be reduced to 1:1 in case of midpoint. So that is here given. The midpoint of a line segment divides the line segment into ratio m1 is to m2 equals to 1 is to 1. Why it is 1 is to 1 once again? When P will be the midpoint of AB, the ratio m1 and m2 will be same. AP equals to PB will be. So AP upon PB will be the same, cut up and down. We will get 1 upon 1. So m1 upon m2 ratio becomes 1 ratio 1 in case of midpoint. So if we place in this m1 and m2 as 1 1, you can understand 1 into x2 is x2, 1 into x1 is x1. So it will be ultimately x1 plus x2 up, and down there 1 plus 1 2. So x1 plus x2 upon 2. This is we have xy equals to, if xy is the midpoint, x coordinate will be x1 plus x2 upon 2. Similarly y point also y1 plus y2 upon 2. Y again 1 into y2 y2 plus 1 into y1 is y1 upon 1 plus 1 2. Here it is m1 plus m2, sorry. So this way we have seen the section formula, and it is x coordinate equals to m1 x2 plus m2 x1 upon m1 plus m2, and y coordinate is m1 y2 plus m2 y1 upon m1 plus m2. And the midpoint formula we have xy equals to x coordinate is x1 plus x2 upon 2, and y coordinate is y1 plus y2 upon 2. Now using this formula we will have the next examples. So in this lecture we will see example number 6 and 7, which is coming after this formula. So example 6 is, find the coordinates of the point which divides the line segment joining the points 4 minus 3 and 8 5 in the ratio 3 is to 1 internally. So this is the same situation as the section formula given. So we will apply the same solution. We want to find out the coordinates of the point which divides. So let the point PXY, the point which we want to find out is taken as PXY, divides the line segment joining the points. Let this point is A 4 minus 3 and B 8 5 in ratio 3 is to 1. So all things if we compare to the section formula, as you know that A is called x1 y1. So A is, we will write smaller way that it is x1 y1 for our reference. B as x2 y2. So B point is called x2 y2. And the coordinates, point of the coordinates which is dividing is called xy, xy, that is we have considered, and the ratio m1 is to m2 is 3 is to 1 here. So m1 is 3 and m2 is 1. So this way we will denote everything comparing section formula. I will use section formula to find x and y because we want x and y. xy equals to the section formula is this whole we have written m1 x2 plus m2 x1 upon m1 plus m2, and y coordinate is m1 y2 plus m2 y1 upon m1 plus m2. Now put all the values here. m1 is 3 into x2 is 8 plus m2 is 1 into x1 is 4 upon m1 plus m2 is 3 plus 1, comma similar way. m1 is 3 into y2 is 5 plus m2 is 1 and y1 is minus 3 upon m1 plus m2 3 plus 1. If you simplify this, 8 3s are 24 and 4 1s are 4. 24 and 4 28 upon 3 plus 1 4. 28 upon 4. 4 7s are 28. So 7 will be the x coordinate. Similarly, y coordinate will be 3 5s are 15 and minus 3 into 1 minus 3. 15 minus 3 will give 12 upon this 4. 12 upon 4. 4 3s are, so 3 will be the y coordinate. So 7 3 are the coordinates of the point PXY. Therefore, the required point is 7 3. So this way, very simply we can find by using section formula when one point is dividing the other 2 points in the line segment joining the other 2 points. Next example 7. In what ratio does the point minus 4 6 divides the line segment joining the points A minus 6 10 and B 3 minus 8? In this question, we are asked to find ratio. Ratio, that is m1 ratio m2 we have to find in this case. and the P point minus 4, 6 dividing point is given. XY is this. A and B are given. A will be x1, y, B into x2, y2 are given. So in solution we will denote in the same way as section formula, because the condition is same that one point is dividing the other two, the line segment joining the other two in some ratio, and that ratio you have to find here. And the point and the line segment joining by 2 points, all points are given. Ratio you need here. So solution we will again go the same way section formula. Let the point P minus 4, 6, which is dividing point, is also called xy in the section formula, you know. So I have written here xy base is minus 4 and 6. P minus 4, 6 divides the line segment joining the points A. Minus 6, 10 is given, that considered as x1, y1, and B 3 minus 8 is given, that considered as x2, y2 in ratio m1 ratio m2. Because this ratio we want to find out, we have considered as m1 ratio m2. This ratio we want here. So we use this section formula separately. X coordinate equals to x coordinate and y coordinate equal to y coordinate. Separately we can use. In section formula, what is x coordinate? X equals to m1 x2 plus m2 x1 upon m1 plus m2. This part only, x coordinate part we have taken. And y equal to y part we have taken. Y equals to this y part is m1 y2 plus m2 y1 upon m1 plus m2. Now placing all the values, this x is minus 4 equals to m1 is m1 because we want to find out, x2 is 3 plus m2 is 2m2, x1 is minus 6 upon m1 plus m2 as it is. Now m1 plus m2 down to the right side is taken on the left side. It will be with the multiplication of minus 4. So we have multiplied these two with the minus 4. Minus 4 into m1 minus 4m1 minus 4 into plus m2 minus 4m2 taken on left on multiply. And this part on the right only, 3 into m1 3m1 minus 6 into m2 minus 6m2. Next step, minus 4m2 as it is written here, and this minus 6m2 is taken on left. It will be plus 6m2 equal 3m1 as it is, minus 4m1 is taken on right, it's plus 4m1 with the sign change. Here plus 6m2 and minus 4m2 will give 2m2, and here 3m1 and 4m1 will give 7m1. So this 2 as 2 and this 7 multiplied part is taken on the left is 2 upon 7. This m1 on right side as it is, this m2 on the left is multiplied, taken to the right is down. So m1 upon m2 equals to 2 upon 7. That is the ratio actually. m1 ratio m2 equal to 2 ratio 7. The answer we got. If you check about the y coordinate also, the same answer you will get. How? Let's see. So in this type of question, when the ratio is asked, if you compare any one side x coordinate or y coordinate, you will get your answer. You will get your ratio. On both the sides, you see, you will get the same answer. See here. Y equal to y coordinate is m1 y2 plus m2 y1 upon m1 plus m2. Place all the values. In case of here y is y coordinate of xy is 6. 6 equals to m1 into y2 is minus 8 plus m2 as m2 y1 is 10 upon m1 plus m2 as well. Similarly, m1 upon m1 plus m2 is down. Take to the left side with the multiply of 6. 6 into m1 6m1 plus 6 into m2 6m2 equal to minus 8 into m1 minus 8m1 plus 10 into m2 10m2. So here 6m1 as it is, minus 8m1 will take on right left. It will be plus 8m1 equal to 10m2 as it is. This plus 6m2 on the left is taken on the right. It is minus 6m2 with the sign change. 6m1 and 8m1 will be 14m1 equals to 10m2 minus 6m2 will be 4m2. So here m1 as it is and this m2 is taken down. This 4 is on right as it is. 14 on the left will multiply is taken to the down to the right side. You can cancel by 2 these two. 2 2s are and 2 7s are. So 2 upon 7. Again we get m1 upon m2 equal to 2 upon 7. That is the ratio. m1 ratio m2 equal to 2 ratio 7. So you can see if the ratio is asked and only one coordinate we have to compare and we can get our ratio as answer. Here we have done and we have seen. seen both the sides, same answer coming. So any one side also we can do. No need of doing both the side. And this type of only ratio is asked then. And how to get section formula, how to use section formula to find any point which is dividing the line segment joining 2 points, that also we have seen in this example. So in this lecture you are suggested to write down the section formula this way and understand it. Midpoint formula also you write down. It will come in the next coming examples, and example 6 and 7 where you write down in your